Hi, I'm Mali Cecere and welcome to this special edition of Earth from Space on the European Space Agency Web TV. After final tests have taken place, the Sentinel 3A satellite will be shipped from Thales Alenia Space in Cannes to Plesetsk, Russia, to be prepared for launch. Recently, we got the chance to see the satellite in the clean room and meet some of the key players in the Sentinel-3 mission. I learned about its payload and applications and shared some of the emotions involved. Let's go take a look. We are here today in Thales Alenia Space in Cannes, and we are in the clean room. Just behind us is the Sentinel 3A satellite, and with me are Payload Manager Constantin Mavrocordatos and Spacecraft and Launch Campaign Manager Kristof Gantois. And let me start with a question for you, Constantin. Can you briefly explain what your job as Payload Manager entails?
Together with my team of highly qualified engineers, I'm in charge for the development of the scientific instruments composing the payload of Sentinel-3. This job started several years ago, first with the establishment of the specification of the instruments, and later throughout the development with the monitoring of the industrial activities, the reviewing of the results, the decisions on how to proceed in front of problems, up to the acceptance of the final test results of the instrument before integration on the satellite. The payload is composed of several instruments, as you know, on Sentinel-3. We have two big optical instruments. First, starting with SLSTR, which has two banana-shaped openings through where this infrared radiometer is measuring the surface of the Earth with very high accuracy of 1/10 of a degree, and over the full Earth, covers the full Earth in 1 or 2 days. On top of this instrument, you see a black square, which is another optical instrument called OLCI. It's able to analyze the color of the surface of the Earth, and in particular over the sea, detect the presence of different constituents like algae, pollution, chlorophyll, and their flow along the coast and in the ocean. And over the land, it's able to detect any changes in the vegetation, the desertification, or the urbanization of different areas. Finally, we have a third set of instruments, which are all microwave instruments, with the main instrument being the radar altimeter that you can see on the front side of the satellite, covered with a white sheet, protective foil. This instrument is able to measure the surface, the height of the surface of the Earth, and in particular over the sea. This makes it possible to measure how fast the level of the sea is rising, how fast the ice is melting, and also over the land it's able to measure the evolution of the height of the lakes and the rivers. This main instrument of the so-called topography mission is helped by other instruments like the microwave radiometer that you can see on the top left side of the satellite with the orange reflector, and with a navigation instrumentation with DORIS on the front side of the satellite with a white antenna cap that visible on top of the radar altimeter antenna, and on the back side of the satellite, not visible on this picture, we have the GPS receiver antennas.
Okay. Now, once the satellite is up in orbit, obviously you just cannot go up there and repair it. So are there special measures taken to ensure that once in orbit, the instruments will work together?
Absolutely, yeah. When we build such instruments, every single component is selected in a very careful way in order to make sure that it will withstand all the environment that the satellite will see during its lifetime. So in particular, the launch environment with high mechanical loads, and when it arrives in space with radiations and evolving thermal vacuum conditions. Once the instrument is assembled, it is submitted to a longer test campaign which lasts several months, and even after that, when it is delivered and integrated into the satellite as a whole is submitted to another long test campaign. So through this extensive tests, we make sure that no failure can happen later due to a negligence or anything that could happen in the early stages. But still, this does not cover everything. Sometimes we still may have failures, and for this reason, every single function of the instrument is doubled. This is what we call redundancy. So in case of a failure, the failed function can be replaced by its redundant one, and therefore the mission is robust against one and even several failures.
Okay, very interesting. And what have been the most rewarding aspects of working on the mission?
You can imagine that building such a high-tech equipment is not always smooth. So there are many difficulties along the path, and resolving these difficulties and succeeding together with a full team of ESA engineers and industry engineers is every time very rewarding, especially when we pass some key milestones like the final test of the instrument and the delivery to the satellite for integration. But I think the most rewarding moment is still in front of us. It will be the moment when we launch the satellite and we'll start operating and producing data that will be used by the scientists all over the world and feed the Copernicus services that in their turn will be able to contribute to the monitoring and the monitoring of the environment of our planet, and making also our life sustainable and better.
Thank you. All right, Kristof, now as spacecraft manager, what does your job entail exactly?
Well, our task was mainly to all these instruments, these beautiful instruments that Constantin described, is to make and build an accommodation for it, to make sure they could fly, they could survive the launcher loads, they can get the right resources in space to operate and to function properly over the many years. So you have to see it, we had a team of very skilled engineers, experts in each of the disciplines, that really followed from concept up to what you see the result here behind me, the final satellite, stage by stage, the development, this is the design, the unit testing, slowly like a little puzzle or like building blocks, all these things were brought together, tested together, and until we come to a platform where we could provide the needed power, the needed data resources to store all the gigabytes of data that are generated by the satellite, have a telecommunication system that can downlink all that to the ground, have a solar array, which you see there behind you stowed, which then can provide the required power to all these payloads. So all these elements, also the structure, the thermal, was followed by a set of highly skilled engineers together with the industry, and to make sure that now when we then put the payloads on board, everything works together, functions together. And so once we are at that stage where everything comes together, we go then to a next step, which is the system testing, where we subjected the satellite to a mechanical, thermal, EMC, basically simulating the launcher environment and also the harsh environment in space, to see that everything works together, and then to make sure that when we are ready for launch, we are convinced that yes, all the systems can communicate to each other and that we can get the required information and data to the ground. So that was very challenging, but now you see the building blocks all fitted together and the result is now here behind me. So
absolutely, just like a puzzle, like you were saying, in fact. So the mission is based on 2 satellites. Now, have you been developing both satellites in parallel?
Yes, indeed. So there's another model of this satellite already standing here in the clean room a bit further, which is half finished. So basically we were developing in parallel all the units, so the onboard computer, the power subsystems, so the batteries, the solar array, every equipment on board has been immediately developed in twofold. So this gave us a lot of advantages. So that means during the development, if there was maybe a slight problem on one unit, we could make use of the other unit in order to make sure that our tight schedule and planning for this satellite, we could meet the targets there. But up to now, everything has been developed in parallel, and this was from the beginning the objective. Yeah.
Okay. Now, Kristof, since you are also the launch campaign manager, what happens once the satellite leaves from Russia?
To Russia.
Sorry, to Russia.
Yes. So, very exciting moment, of course, because finally we are at that stage. So it means, first of all, it's a very logistic operation. We fly with an Antonov from Nice going to Arkhangelsk. There we will have to load the whole satellite and all the equipment onto a train. Then we have another 1.5 day transport by train towards the launch base, which is a military base 800 kilometers north of Moscow. So we're there really in a very remote location with a very tight schedule in front of us, because we then have to make the satellite ready for launch. So first of all, we'll then check whether the satellite has survived all the transportation, and then after that's confirmed, we will prepare the satellite for its final destination. So you have again the team of highly skilled engineers that will, every task we do there is very well prepared and planned. We will have fuel the satellite. We will then remove all the red tags you see still on the satellite, and then we will mount it also on the launcher adapter, and then further continue with our operations with the launcher authorities there. So we will then have to mount the satellite on top of the upper stage of the rocket, and then once the fairing is closed, we are in the hands of the launcher authorities, and then in the last 6 days before launch, we are really then rolling out the satellite towards the launch tower and really waiting for the countdown and the moment, the supreme moment when we can see the satellite and the launcher going up into space.
Well, thank you very much. I know I can't wait to see it. So, Kristof, Gantois, and Constantin, Mavrocordatos, thank you so much. It was most interesting. And from Thales Alenia Space, goodbye, and thank you for joining us.